Hello, hello. So let's talk about this problem number one. Keep in mind for any of these problems, you can pause the video at any time, and you can also try these out beforehand, see how you do, and then you can kind of scroll through at any point in these videos and see what you need. You don't have to watch the whole thing. You can watch it multiple times if you need to. We'll get started with part A. So we need to find the height of EB. So that's this back dashed line right here. The most useful part for me to look at is going to be this triangle on this far side. So I'm going to go ahead and actually draw out that triangle separately. Alright, so I've got this triangle drawn right here, ABE. I just copied it from ABE. I've got my 23 degrees in the bottom left, angle A. Angle B, I didn't draw it, but it is a 90-degree angle. And then what you should notice is the bottom of this triangular prism is well, not a square, but a rectangle. So if this bottom length, DC, is 15 centimeters, then this top length, AB, is also 15 centimeters. So I'm going to go ahead and label that. And I've got a triangle that I can work with here. So I've got my right angle, which means the side that I'm looking for is the height of this triangle. I want to look at my trig functions. So SOHCAHTOA, hopefully you are familiar with that and remember it. We've got angle A, so I want to relate the opposite side and the adjacent side. So I want to work with the tangent of 23 degrees equals opposite, which is what we want to know, over adjacent, which is 15 centimeters. So you need to multiply both sides by 15, and you end up getting 15 times the tangent of 23 degrees equals x. It's a little bit easier when you do this on paper, but if you calculate this, you're going to get the height, EB. So I calculated that. I got 6.37 centimeters if I'm doing 3 sig figs. I also wrote down the exact answer just in case I need it for future work. You don't want to use rounded answers to get answers in the future. So I always make it a habit to write my full answer just in case I need to use it for a problem down the road. If you didn't get these, make sure your calculator is in degrees. If you borrowed one or if you have your own graphing calculator, most online things default to degrees, and if not, you can usually put that little degree symbol in there. Let's talk about B. So find the length of DB. If you look between D and B, there is no line, so we have to create it. I am going to draw ADCB. I'm going to draw that little bottom square so you can see it, and then I'll draw in that line DB. So I'm going to pop that up real quick. Alrighty, so got this rectangle copied down. I have AD right here, it's 23 centimeters, and then the bottom part of this, DC, is 15, so I've got DC labeled 15. If you wanted to, you could label the entire rectangle. Opposite sides are the same length. And it's asking us to find the length of DB. So I'm going to draw in that diagonal. This is the actual value that we want to find. We want to find this length right here. So I'm going to go ahead and call that X. That's the value we want to find. A rectangle, it's got all 4 angles are right angles, so I have 2 right triangles here. Length 15, 23, and we want to find the hypotenuse. Because this is a right triangle, we can use Pythagorean theorem. So we got a squared plus b squared equals c squared. And you should know that c squared is the hypotenuse. So we have our A value 15 plus our B value 23 equals our C value, which is x, and that's squared. So in order to solve for x, you need to take the square root of both sides. So I take the square root of both sides. The square root of x squared is just going to cancel out to x, and then I have to evaluate this left-hand side. So go ahead and do that, see what you get for your answer for x. Two answers here. I've got my 3 sig figs, 27.5 centimeters, and then I've got my full answer written out here as well. Make sure you include your units. So our units here are centimeters, that's the length of that diagonal, and that is dB. So that's part B. Part C, the length of the line DE. So that one is also not in this diagram. We have to draw it in. And DE is on the plane ADFE. So if we draw ADFE, I'm going to take a second to draw that diagram. You can do that yourself as well. We'll label the sides, everything we know, and then we'll figure out how we find that length DE. So I drew out that face ADFE. We know AD has a length of 23 centimeters. And we haven't calculated AE, we have not calculated DF, and we have not calculated EF. The question is asking us for DE, so I'm going to draw in that length that it's actually asking us for. Alright, so that is our X, and we need to figure out what information we need to make this easier to get our X value. So I don't know any of these angles other than, angle F and A are 90 degrees. This is a rectangle up top. So I know it's 90 degrees. I know this is a right triangle. If I could find AE and find the length of that side, then I can do Pythagorean theorem again to get my value of X. So let's look at how we could find AE. If we look back at our original diagram, and the first triangle that we did, we had AE, B, we had this triangle right here, and we found the height, EB. We knew that the base was 15. We found the height to be 6.36712243, so we already have that answer for the height. So you could do Pythagorean theorem with those two values and find this hypotenuse, which would be AE. The other thing you could do is you can go back to that original triangle that we had, and you can say, well, instead of relating the opposite side and the adjacent, what if I related the hypotenuse and the adjacent? So hypotenuse and adjacent, we would be using cosine. So you could do the cosine of 23 degrees equals adjacent. So the adjacent side is that 15 again, divided by the hypotenuse, which is, I'm just going to call that AE so we can keep that straight, that it's this length right here. Now, when you multiply both sides, if you want to solve for AE, you cannot multiply both sides by 15 because 15 is not in the denominator. So if you multiply both sides by our unknown, which is AE or X, you would end up with AE times the cosine of 23 equals 15, because that denominator of AE is going to cancel out when you multiply both sides by it. And then we have to divide both sides by cosine of 23 so that AE is by itself. So we get AE equals 15 divided by cosine of 23. If that was a little hard to follow, try setting this up yourself with that original triangle. It'll make more sense when you're trying this on paper. So pause the video, see if you can get that yourself, and then press play, and I'll have that answer up there for you for AE, and we can solve for our answer X. I got my answer 16.29540566. There is definitely a reason that I did not round that answer. This is not my final answer. It is just part of my work. So I'm not going to round an answer until it's my final answer. And I'm going to go ahead and label this side AE that we just solved for. And now I can do Pythagorean theorem with these two and x. And x is the hypotenuse in this situation. So you're doing 23 squared plus, in your calculator, I would do ANS, which is the answer. So you're getting this entire value. The other option is to do 23 squared plus, type in that whole value, 16.29540566. You're squaring that, and it equals x squared. And then you're going to solve it by taking the square root of both sides, and you'll come back with your answer for x. So try that out, see what you get for x. So I've got my 3 sig fig answer, 28.2 centimeters, and my full answer. This is our final answer, so you can give it in 3 sig figs is just fine. That does it for part C. For part D, the angle that line DE that we just found, the angle that that line makes with the base of the pyramid, ABCD. This rectangle on the bottom is the base. So we want to know what angle does this line make with the base. So let me draw a triangle really quick just to show you where we're looking at for this angle. Alright, so I drew this triangle. We need to know the angle D, or the line DE, what angle it makes with the base. So the base, remember that original line that we drew in part B, line DB, that is on the base. So we have DE, we just solved for. I'm using the full answer, so it's important that we write that down and have it. And I'm using DB, which is the length on the base from D over to B. And I want to know the angle that that line makes with the base. So what it's asking me for is it's asking me for the measurement of that angle X. Now this is a right triangle, so we can use our SOHCAHTOA. We want to relate the hypotenuse and the adjacent side. So we want to use cosine. The important thing to note here is that we're solving for an angle, so we want to use the inverse cosine. So we want to do inverse cosine of the adjacent over the hypotenuse. Here's my equation I'm setting up. Inverse cosine of the adjacent side over the hypotenuse. And that is going to give me the value of that angle. So if you don't know where that comes from, take a peek, look back at your trig functions, and I'll pop up the answer real quick. Final answer, I'm going to round it to 3 sig figs, is 13.1 degrees. Degrees is my units. That is the measure of that angle. So that is part D. My advice when you have problems that have multiple parts like this, even if you're rounding your answers, make sure you write down the full answer. If you weren't writing down your full answers and you used rounded answers for your adjacent and hypotenuse, you might not get 13.1, and that's bad news bears. So make sure you're writing down your work as you go. Write down those exact answers as well as those rounded ones. Remember, exact answers are fine too. You don't have to round it unless it tells you to. If this was confusing, if you have any questions on this, let me know. Shoot me an email. More than happy to help you out if you have questions on specific parts. Peace.